Hello everyone and welcome back. In today's video, we are going to talk about the fundamentals of Linux permissions, breaking down the roles of owner, group and others. We will look at what happens when a user tries to access files that he does not have permission to access, and also we will see how to set these permissions using both symbolic and numerical methods. But we are not stopping here. We are going to take this knowledge a step further and discuss why these permissions are crucial for system security, especially in preventing something known as privilege escalation. So, without further ado, let's get to it. So let's begin by talking about Linux permissions. And Linux permissions are a fundamental aspect of the system's security and management, controlling user access to files and directories. The traditional model is based on assigning to files three different permission categories of users. These three categories are the owner, as you can see here, the group, and others. Each of these categories can have different levels of access to files and directories that are defined by read, write, and execute. So let's relate each category of users to their respective levels of permissions. So, the owner is typically the creator of the files and directories. The owner has the authority to set permissions for themselves, the group, and others. Then we have group. This consists of a set of users who are assigned to a group that can share the same permissions. Each file and directory is associated with one group. And we have others. These are users who have access to the system but do not own the file and do not belong to the group to which the file is assigned. Now, when we discuss permissions, it's important to know that they are not spelled out fully, such as read, write, or execute. Instead, they are represented by letters. So, the read permission is represented by an R, as you can see here on the screen. The write permission is represented by a W, as you can see. And the execute permission is represented by an X, as you can see here. And taking this example here on the screen, if we look at the owner's permissions, we can see that the presence of an R, this one here, indicates that the owner can list the contents of this directory. If there were a dash instead of a D, it would signify that this is a file, not a directory, and the owner could read the contents of that file. So, with this here, you can see if this is a directory with a D or if it's a file with a dash, okay? And because the owner has a W, it means that the owner can add, remove, or rename files within this directory. If this were a file, the owner would have permission to modify its contents, okay? The X means that the owner has permission to enter the directory and access files and subdirectories contained within it. If this were a file, it would mean that the owner could execute the file as a program or script. Now be aware that all these permissions can be applied to the group and others as well. The permissions are often represented as a string of characters. For instance, this permission here, as you can see, means for the owner that he can read, write and execute the file. In this case, it's a directory. For the group, that the group can read and execute. And for the others, that they can't do anything because they don't have an R or a W or an X, okay? However, permissions can also be represented numerically using octal numbers, like so. So the number 4 stands for read, the number 2 stands for write, and the number 1 stands for execute. So when we have a file with the permissions R, W and X, numerically these permissions are represented by a 7 because 4 plus 2 plus 1 is 7. So for instance, a file with these permissions could be represented as 7, 5, 4. 7 for the owner, as you can see here, 5 for the group, and 4 for the others. 7 for the owner because he can read write and execute. So you need to sum all these here. That will give 7, 5 for the group because the group can read and execute, and 4 plus 1 gives 5, and 4 for the others because they can only read, okay? Now I will show you in my Kali Linux what happens when a user tries to read a file that he does not have permissions to read, and what happens when he tries to change of directories when he does not have permissions to do that. So I'm Sabatista, and if I run the command who am I, you will see that I'm Sabatista, and I am the owner of all the files and directories that are inside of this directory called permissions, as you can see here. So when I use the command -l, I will have access to information such as the permissions for the files and directories here, who owns the files and directories, the name of the group that has access to those files and directories, the name of the files and directories, the size of the files and directories, and the date and time when the files or directories were last modified. As you can see, because I'm Sabatista, I have access to all these files and directories. You can see it here on the permissions. Now, I created a new user called tester, and this user can see the contents of the directory permissions, so this one here, because he has permissions to do that. But from these files here and their permissions, what do you think that will happen if the tester user tries to see the contents of the file example.txt? What do you think that will happen? Well, let's see. I will switch from my account to the tester's account, and I will try to read the file example.txt. I will use the sudo command -u tester bash. This command starts a new bash shell session under the user identity tester. This means that any commands you type in this new shell will be executed as if you were the user tester, not as your current user, so not as Sabatista. Also, it's helpful to remember that the bash shell is the program running inside the terminal that processes and executes the commands you type. Click enter, insert the password, and if you run the command who am I, you will see that here I am the tester, okay? So here I'm Sabatista, but here I'm tester. Now let's list what's inside of the permissions directory, just for you to see that the user tester can see all the files and directories inside of permissions directory because he has permissions for that. -l. So as you can see, the tester user can see all the files inside of permissions because he has the permission to see all the files. But now let's try to read the contents of the file example.txt. So cat example.txt. Okay, as you can see, the user tester can see the contents because he does not have permission for that. Now, if you look here at Sabatista account, you will see that the tester user can't access the directory called examp.dir, because if you see here in the others group, they can't see anything, they can't write anything, and they can't execute anything. And our tester user belongs to the others, okay? So if you go back to the tester's account and try to change of directories to the examp.dir directory, you will see that the tester can't do it because he does not have permissions for that. So let's try it anyway. So cd, that stands for change directory, and then the name of the directory examp-dir. And as you can see, the permission was denied because he does not have any permission to read or execute, okay? One thing that is important to tell you is that if you want to see what groups you are a member of, you can use the command groups, so let's use it here. But as you can see, it does not belong to the group Sabatista, so it does not belong to this group that is associated with these files and directories, so these files here in directories. Otherwise, when we run the command groups on the tester shell, we should see not only the group called tester, but the group called Sobatista. Since it does not belong to the Sobatista group, regarding these files and directories here, it falls into the others category, okay? So now you know how to see permissions, how they look like, how you can verify the groups that you belong to, among other things. Now let's see two ways that we can use to change file permissions. So to change file permissions we need to use the command chmod, that stands for change mode. However, what comes next is what changes. So we can change file permissions using their numerical representation, which I talked about at the beginning of this video. And let's do that to a file that our tester user can see the contents of. So we already know that he can see the contents of the file example.txt. Now let's give to the tester permission to read the file example.txt, but using numbers. So do you remember what is the number that represents the read permission? Well, the number is 4. So the command will be like so. Chmod 754 and then the name of the file, in our case is example.txt. But before we execute this command here, when we have this permission string, numerically it's represented as 750, okay? Because it's 7 for the owner because he can read, write and execute. It's 5 for the group because the group can read and execute, and it's 0 because the others can't do anything. So now let's run the command and see if the others now can read the file, okay? Okay, as you can see now, the others can read the file. So let's read the file as a tester. We go to tester bash, we insert the command cat, and then example.txt. And as you can see, we can now read the file example.txt, okay? Before we couldn't do that, as you can see here, but now we can, because we gave the group permissions the permission to read. Now, let's change the permissions of the directory called examp.dir so that the tester can change to this directory and read its contents. However, we are going to use the other way, where we use letters instead of numbers. So, we use the command chmod, then O plus RX, and then the name of the directory, examp.dir. In this command, the O stands for others because the user tester falls into the others category. The plus is used to add permissions, and the R and X are the permissions that we want to grant to the others category, which includes tester. Now you click enter, we insert the command lns-l to see if the permissions were changed to the others category, okay? And as you can see now, the others category can read and execute the examp_dir directory. Now, let me just tell you that if instead of adding permissions, if you want to revoke permissions, you can use the minus signal. So, instead of a plus, you can insert a minus, okay? Also, if you want to change the permissions for the owner, you can switch this O here with a U that stands for user, that is the same as owner. If you want to change the permissions for the group, you use a G, so it will be like this, and for all, you can use an A, okay? Now let's go to the tester bash shell and change of directories to see if we can do it. So cd examp_dir, and as you can see, we are now inside of the examp.dir directory. Remember that we couldn't do that before, but now we can. So let's list what's inside of example dir directory. Okay, ls, and here we have other directory and a file called file2.txt. Now let's talk about privilege escalation. Privilege escalation might sound like a complex concept, but it's actually a direct extension of what we've been discussing. At its core, privilege escalation occurs when a user or a process gains higher access rights than intended, and it can lead to unauthorized control over system resources. Permissions in Linux act as the first line of defense. They dictate who can read, write, or execute files in directories, correct settings, ensure that only authorized eyes see sensitive information, and only approved hands modify critical files. When these permissions are misconfigured, they become a gateway for attackers. So imagine a scenario where a script that should only be modifiable by the admin has write permissions for all users. A regular user could insert malicious code into this script. Then, when executed by an admin, it could potentially compromise the entire system. This is a simple yet powerful example of how incorrect permissions can lead to privilege escalation. And this is just scratching the surface. To give you all a more comprehensive understanding, I'm excited to announce that my next video will focus solely on the topic of privilege escalation. We will examine special permission settings like SUID, SIGID, and much more. So, in summary, the permissions that we discussed in this video aren't just about control. They are about security. They are about ensuring that escalation of privileges remains a theoretical risk, not a practical inevitability. As you continue to manage and use Linux systems, keep this in mind. Every file, every directory, every script is a potential security risk if not properly secured. So, let's stay vigilant and ensure our systems are as safe as they can be. Thank you for watching, and stay tuned for more insights into Linux and system security. Don't forget to like, subscribe and comment if you have any questions, or even if you have topics you'd like me to cover. See you next time, stay curious, stay safe, and keep sharpening those Linux skills. Bye bye!